been quite enough time, but we'll just go through it to make sure that we get through it. Okay, so part A, find the displacement. They ask that a lot. Displacement just means how much did it travel total. I shouldn't say that. Displacement is like how much is it different from one to the next, so from where it started to where it finished. So all I got to do is plug in 5 and plug in 0 for position and subtract them. So that's going to tell me the total displacement. So it doesn't really care if you go like up a lot and down a lot and up a lot and down a lot. It cares like what was the total amount of change in that time as far as where I started and where I stopped. So the difference is 10 meters. The average velocity and instantaneous velocity are really important topics. The average velocity is what you would have found if you'd never taken calculus. The average velocity is basically the slope. It's the position at 5 minus the position at 0 over 5 minus 0. That's going to tell you the average amount that it changed from one point to the next. So it's like taking 2 ordered pairs. Wherever I was at 0, comma, its y value, at 5, comma, its y value, I'm just subtracting the y's on top, I'm subtracting the x's on the bottom, and that's my average rate of change. I got 2 meters per second. Because if I had something that like changed a bunch from 0 to 5 seconds, well maybe its average rate of change was 2, but it had a bunch of different rates of change as it went along. So then the question C is saying find the instantaneous velocity. This means the derivative. The derivative of position. If it wants you to find the instantaneous velocity, that's what you're finding when you take the derivative of position. So the instantaneous velocity is the derivative of s with 4 plugged in, and I got 5 meters per second. This is the whole beauty of calculus, that the rates are going to change. That from time 0 to time equals 5, I have an average rate of change of 2 meters per second, but the rate of change at 4 was 5 meters per second. That's different. So that's an important thing to understand, that something that's an average is going to be different than something that's at that exact second, and that's what calculus allows you to do. So d, the acceleration is 2. Sorry, I just finished this really fast. At what value of t does the particle change direction? So the particle is going to change direction again when the velocity is 0, because the velocity is going to be moving into the, it's going to tell us what direction it's moving. So as it's positive, it's going to go one direction. Once it turns negative, it'll go the other, and in between, it's going to be 0. So this happens at time equals 1.5 seconds. And when is the particle at a minimum? This one's a little bit tricky. When's the particle at a minimum? So when the velocity is 0 is when the thing changes direction. So since my particle is going back and forth, it only changed direction once at time equals 1.5 seconds. There are more calculitic ways to figure this out, but this has to be when the thing was at a minimum, because it changed direction and only changed direction once. So we have to think that the velocity before 3/2 was negative, and the velocity after 3/2 was positive. And it changed direction, so that therefore it was at a minimum when that direction change happened. So I'm going to take 3/2 and plug it into position to find out where it was at that time. Does that make any sense? I hope.
Why is that a minimum?
I should actually go into this more in depth, but the bell's going to ring in a second. If I looked at the velocity just before 3/2 of a second, and I looked at the velocity just after, it's actually going to be negative before this and positive after it. So meaning the thing's going to the left and then going to the right. So at that spot, when the velocity was 0, it would be at a minimum. So I'm going to take that time and plug it in.
Okay.
But I actually should use more calculus, but that's, I'm not going to take the time to do it. All right, for homework. It's not that much.
It's a lot already.
It's really not. One is really short. I'll even make it shorter.
That's good right there.
4 problems.
You can't even count that high. Jimbo, you better win today.
Jimbo!
Is this still on?
It's on, yeah.
Hi, Jimbo.
Jimbo's winning right now. Jimbo better be
There's the
winning.
homework.
Jimbo's a failure. Hey, Jess! Yeah!
This is everybody who's here.
He's a failure.
Kirsten's here too.
You're not even starting that.
Oh, what was that thing you told me about Monica?